Okay, here's an example where it gives us two means and two standard deviations. So it's comparing males and females. So the heights of male teachers and the heights of female teachers. So I'm going to circle all the data that I have. And it wants us to describe the distribution of differences. The first thing that I want to write is that they are both, so the differences are also normally distributed. So normal. Then I want to find the mean of the differences and the standard deviation of the differences. So male minus female, male minus female. And we know through Statland that we can combine means and standard deviations by finding the difference in the means. So if I'm doing male minus female, it'll just be 70 minus 65.5, which is 4.5. And standard deviation, I square root 2.25 squared plus 2.5 squared. And it's always plus, no matter what.
So you just add square
add square root. Mm-hmm.
Whether we're combining.
And you should get, because it's the standard deviation, not the variance. Mm-hmm. You should get 3.3634. So then it asks me to find the differences, but it's also going to ask me the similar types of questions, like normal CDF questions, inverse norm, based on the differences. So it says, what's the probability that a randomly selected male teacher is shorter than a randomly selected female teacher? So once you have combined your data, you will never go back to the individual numbers. You will only stick with the mean and the standard deviation of the differences. So my mean was 4.5. My standard deviation was 3.3. What was it? 36. 35. 34. Okay. So these are the only two numbers I am now dealing with. I have forgotten about the individuals. I have now combined them to be the differences. So differences, male minus female. And I've got a new normal curve of the differences where the mean is 4.5. So here's my picture. And it says, what is the probability that a male teacher is shorter than a female teacher? So if I think about male minus female, if I think of male minus female, if they were the same height, then the difference would be what? 0, if they were the same height. If males were shorter than females, what I have, so if they were the same, it's at 0. If they were the same, anything negative would mean that male is what? Shorter.
Because there's subtracting male minus female.
Yeah, if I'm doing male minus female and I get a negative number, that means that females are taller and males are shorter. So I want all my negative numbers. And so to do a normal CDF of that, so here's my 0 down here. I want this shaded area. Everything where male minus female is a negative number.
So 0 is your max.
So 0 is my max. So I would do a normal CDF of negative infinity to 0. But I'm going to use my new mean and standard deviation. So 4.5 and 3.3634.
So what is this number that we're finding?
That is the probability that males are shorter than females.
Pretty cool.
9% chance.
What?
No, you shouldn't get
I
that.
got point.
Oh, 9%. Did you say 90?
I said 9.
Oh, you said 9. Okay. You should get 9.
Right? We're close. Dang it. Why did I do it wrong again?
And this right here, the z-score thing, remember that's the long way. You don't have to do it the long way. So here's just kind of a sum of all the things that we learned on the calculator. We don't use normal PDF, so you can just cross that out. We don't use it. We don't, because we don't graph. Normal CDF is whenever it asks you to find the probability. Inverse norm is whenever you're trying to find a z-score. So like if you're given a percentile.
What would it look like when you're given a z-score? Would say z-score is this?
You would probably do normal CDF.
Yeah.
Because -1 to the 99 is
just -1. Mhm. Right.
Or give us
Okay, let's do a few more examples. So it gives you, it says data on the length of time to complete registration for classes using an online registration system suggests the distribution of the variable x equals the time to register. It says that it's normal, so underline that. Gives me a mean of 12 and a standard deviation of 2. And it says, what is the probability that it will take a randomly selected student less than 9 minutes to complete the registration? So I want to find the probability, whoops, that's my highlighter, probability that x is less than 9. If I draw my picture, I'm going to put my mean in the middle at 12. I've got 9 here, and I want this shaded area to the left. So normal, CDF, -2 to the 99, 9, 12, 2.
I understand that.
That's what most of them are like. And it's, don't let the this fool you. This is the long way. So all on the PowerPoint, it's always the long way. But we do the shortcut way. It's just showing you the long way that you could do it. What is the probability that it's more than 13? What would I do?
13 is your
Change your
mean.
max to infinity and make your lower bound 13.
So normal, CDF, 13 to infinity, 12, 2.
-0.691. What? Oh, is that wrong?
Yeah, you won't get a negative in
Why?
probability.
I literally typed it in.
That would be
What's
like
wrong with this?
6,900%.
Why is it
wrong with
99 the
this?
same thing?
Oh, I
No.
put negative as the
Why does
upper
my
bound.
calculator automatically say that?
If it says negative
negative
1e to the 99th, that is okay. But negative 1 to the 99th is not okay.
Oh, okay, it says
Don't do that. Yeah, if it has an e. That e is like saying times 10. So times 10 to the 99th power is what this e is.
Is it the same?
I usually do negative 2 to the 99th unless,
Why isn't there an infinity button?
I don't know.
You should make
Waste of a
that.
button.
It is.
Decide right there.
Us
I
mathematicians
disagree.
don't need
It
that.
saves me a lot of time and
Shortcut.
stuff.
You should get 0.3085.
I got that.
Okay.
Mine doesn't say
You should
zero
get
point
negative
one
6.
on that.
What is the probability between 7 and 15? How is that different?
Ooh,
I guess.
that's a good
Wait, I
one.
forgot.
You don't
Lower
use that.
bound
Can't
is
find the
7,
area.
upper bound is
You just do
6.
7 and 15.
Oh, it's easy. I can't win.
Slow down.
Normal CDF, 7, 15, 12, 2.
Point negative. I'm kidding.
Don't say it out
I'm
loud.
kidding. I'm kidding. I should have learned that by now. But always wait till someone else says something, then I'll.
Wait, so on this one, why don't you do the upper or the infinity?
Because I'm not going out to negative or positive infinity. I'm in between two bounds. So it's between 7 and 15.
I don't like that. Oh, this one's funky.
Yeah, so we do the second one. Okay, next one. So it says, because some students do not log off properly, the university would like to log off students automatically after some time has elapsed.
That's annoying.
It is decided to select this time, so we're looking for a time given that only 1% will be automatically logged off when trying to register. So I want 1% to be, like the top 1% needs to be logged off.
How do you know it's the top?
Because if I have a normal curve, and my x is minutes, right? So who's going to be logged off? The people that spend the most amount of minutes on it or the least amount of minutes?
Most.
The most, right?
Oh, the minutes on the computer.
Minutes on the
So
computer.
logged off the computer.
Like they keep it on, so it's technically
people
logged
use it
in their
The
name.
1% that uses
And
the
time
most
goes by and it's still going by and time. They're logged on, but you've gone off and done something else.
Oh, I thought you said logged off.
No, they're not. So what the computer wants to do is it wants to automatically log these people off that spend a lot of time on it because they left it. So I want to log off 1% of the population. So I'm going to go here to the 99th percentile
Oh, I did not see
because that means that 1% spend more than that amount of time on the computer. Does that make sense? So this is an example where I would do 1 minus that. So to find this value, it's given a percentile. Remember, I do inverse norm of 0.99. My mean is 12. My standard deviation is 2.
So use inverse norm.
Mm-hmm.
Because you were given.
Wait, so how come we didn't do 0.01 on this one?
Because it says they want 1% to be automatically logged off. So that means they want 99% to not be logged off. So that's why I encourage you to draw a picture and think, am I shading above it? Am I shading below it? Do I want the top 1% or do I want the bottom 1%? Because when I do the bottom 1%, that means that 99% would be logged off. You don't want that to happen. You only want 1% to be more than that time. You want 99% to be less than that time.
So how do you know when to use normal CDF and inverse norm?
Normal CDF is when it asks you for a probability. So it's saying, like, what's the probability between 7 and 15? You do normal CDF. And then this one, it's giving you a so it's giving you like a percentile, and it's asking you to output a value.
Wait, so we put in 90, we put in 99% because, like, say that again?
We put in 99% because we only want 1% to be logged off. So we want, if you look at the picture, like I want the top 1% to be logged off. So the people that spend more than 16.66 minutes on the computer will get logged off. That's a long way to do it. I showed y'all both ways, but I think the second way is faster.
So we'll never have to use.
The only time you have to use the z-score formula is whenever you're not given, like it's asking you for mean or standard deviation.
And that's x minus mean over standard deviation.
Yes.
Equals.
Okay, last thing, and then we're done. So, ways to assess whether something is normal or not.
Oh, wow.
So far, we've only been able to tell based upon you have, like it gives it to you. Like it says that it is normal. However, there is another way to tell, and that's given a normal probability plot. So, essentially, we did this kind of in the first part of the, like, I think it was like unit 2 or 3. But essentially what a normal probability plot is, it is a scatter plot. So a scatter plot, it's a scatter plot where here's my scatter plot. This is my x, and then these are my z-scores on the y value.
Uh-oh. Are we about to be doing like...
And we want it to be linear. So we...
I'm done.
Is this on the quiz?
There goes it.
No.
Oh, gosh.
We want it to be linear.
We're
Okay?
gonna do like residuals?
No.
Oh, okay.
Wait.
So...
It should be...
Here's the sample with, let's say that our sample size is 5. If I were to divide the normal curve into 5 parts, each area would be about 20%. Why are these regions not the same width?
Because they're not the same height. So
Because of the height, exactly, because of the height. If I found the median, this is just kind of showing you the long way. Median is the middle. Why are these not equal widths apart? Because of the height.
What does that mean? Why does the height affect the width?
Like, because if you're doing the area under the curve, you take into effect, yeah.
That makes sense.
Oh gosh.
So we're going to actually use our calculator to compute normal scores.
technology.
We want a linear pattern. If it's not linear, then we say it's not normal. That's basically the premise of it. Right now, we're only going to look at normal probability plots. We're not going to calculate them. Okay?
Yay.
So, would this be normal or not?
I don't know. Look at that
No,
top.
it's not.
No, it's got a curve.
It's
Yeah.
linear.
What's the
That's a
pattern?
curvy little...
You want a linear pattern. So we don't want a curve.
No. We don't want outliers.
We don't want an outlier.
No, we
Malcolm
don't.
Gladwell.
Funny one.
So in your calculator, what I want you to do is I want you to type in these x values into list 1. Wait, hold on. Sorry, go back. Type in the green ones. Type in the green ones. Sorry.
All my
All
progress.
list one, right?
Type in the green ones.
As list one?
Yeah. So you should just have the green typed in. Do not type in the blue.
Why isn't that? That's purple, that's purple.
That's violet.
Blue.
I think it's purple.
From there, what I want you to do is I want you to go to second y equals.
No!
Nope.
Calm down. Oh my God.
Boo.
Second y equals, I want you to turn plot 1 on. For the type, I want you to go to the bottom right. So you're going to have to hit the right button all the way past the box plots, and it's the one that looks like this. It's the bottom right one.
Oh, wow. Oh.
Okay.
What's this?
Everything else should be the same. List 1, data axis is X. Then from there, I want you to hit zoom 9.
Yeah.
Zoom 9.
Ah, that's
And it says error.
It's linear.
You should have nothing in your y
So
equals.
linear. Whoa. Now let's take the quiz. No.
You should have one that looks like this.
That is so wrong.
Is that linear?
Yes.
calculator keeps drawing lines.
I don't know what I
You must have something in your y equals.
That's wrong.
Make sure that your functions are cleared out.
So why do I have this line?
That's very
I don't know.
It's linear though.
Oh, wait, there's a residual.
How do I change this?
Zoom 9?
So if I were to describe this, I would say since the normal probability plot is approximately linear, the distribution of egg weights is approximately
It's not like egg
normal.
whites. Do you have some egg weights?
Egg weights.
Egg weights?
Y equals and
Let me
Classic.
tell you.
So classic.
That's funny.
no, you.
Remember, you can also use box plots, and you want your box plots to be symmetrical. So you want normal probability plots
Linear.
to be linear.
Yeah.
You want your box plots to be
How
symmetrical
do you know if it's linear?
Quit.
Subjective.
by looking at it.
Tissue.
It doesn't look
Oh,
like
my
Back to
one's
those
all
patterns
weird.
where we're always wrong.
Right. The box plot has an outlier. The normal probability plot will have an outlier.
If it's not linear, then what is it?
It's not normal.
Is it snowing?
No, it's not.
It's snowing?
And then if it's skewed,
80 degrees.
It's snowing freshman year.
Or
then you would also say that it's not normal.
So you want the outlier or no?
You don't want the
So it
outlier.
should just be a stream.
So these are both bad. These are both bad.
Okay, I just want to clarify. Okay, that's good to know.